This lesson is going to cover this demonstration will cover the content of lesson 3. I'm going to go ahead and use Visual Studio Code. I think it provides a good balance between features and the ability to preserve the IPython notebook, which can be useful. So I'm going to go ahead and start by opening lesson 3. I downloaded all the content from the course and just saved it into a folder called course. Then I'm going to let Visual Studio Code import the file. So I'll get a magic Python file. And here we are. So I will save that as lesson 3. And now we have the magic Python file. So what this has is some code that Visual Studio has introduced, which is this first block here. It's trying to make sure that we're in the right directory. That's usually not incredibly important here. And then what we have is we have all the markdown blocks with some cell blocks to actually put code. So this is how all the assignments are going to go. All the lessons are going to go. We will just use the markdown that's there. Will tell me what we're going to be doing, and then we'll work through the solutions and we'll try to provide some explanation where needed. So the first cell that has a problem in it asks us to, I can go ahead and run it, and then we can see it. It asks us to just create some basic variables. The names for variables in Python have rules. These rules are fairly simple. In most cases, you should start your variable with a letter. After the letter, you can use a mix of lowercase, uppercase, numbers, and an underscore. It is possible to start variables with an underscore, although in Python programming, when a variable starts with an underscore, that actually signifies that the variable is so-called private. And so usually in most code, you want to avoid that unless you're intentionally trying to communicate something either to yourself or to someone else that this is an unimportant variable or a variable that they shouldn't rely on. So here in this problem, we're asked to create a couple of variables, scalar float, scalar int, and then we'll use the print statement, which is a function, to actually print out the output. It's important to note that in Python, you don't generally get any output shown to the screen or into the terminal. The only exception to that is if the very last line of a cell does not have an assignment to the variable, then that line will actually be printed. But any other lines with or without an assignment above them will never be printed. And so it's often the case that we need to use print when we want to explicitly see the output of a variable, the value of a variable in the middle of running a program, or if we want to save it so we can copy it to another file. So to get started, we'll just enter our variable names here. So we have scalar float, which again, Visual Studio Code is just sort of reading what I have in the file, and it's actually anticipating what I want to put here. So it asks me to put pi to 4 digits, which is 3.1415. And that's it. There's no need for a semicolon or anything to indicate that you have finished the line. We can also do scalar int. And there we're asked to just put 31415, which of course is the same number, but this is an integer. In terms of numeric types, what we care about in Python, there are 2 types. There are floats and integers, and they are different. So floating points are things that have decimal points in them. They behave according to one set of rules in terms of how you add and subtract and multiply them. Integers behave according to a different set of rules. In particular, if you take 2 integers and you multiply them together, you always get an integer. Whereas if you multiply an integer and a floating point number, you're going to get a floating point number. So this every once in a while can be a little bit of a gotcha, although in Python 3, this is much less of a problem than it used to be in old Python, where things were much more dogmatic about the types. So now that I have these 2 variables, I just want to go ahead and print them out. So I'm going to use a function, print. When you have a function, you type the function name, and you're going to have parentheses, and then obviously you have the input here. Visual Studio Code has popped up the help file for print, But in most cases, we're just going to print the variable name itself. So I'll just type print scalar float and print scalar int. Again, with code completion and things like that, it makes it a lot faster to actually type the code in this sort of development environment, which is one of the reasons why I like Visual Studio Code. So just run the cell, and you can see I see the values of my two variables. Of course, what I'm actually seeing here is I'm not seeing the first two lines where I define the variables. I'm actually seeing the output of the print statements. So once you've done that, you have created some very basic variables in Python. A lot of times, though, when you want to output things, you want to actually have a more meaningful representation. These two numbers by themselves don't really tell me much about what's going on. So we need to have some strings as well. So the next task asks us to create some variables, some string variables. The first one is simply called a string, and it's going to contain the text called "this is a string." So I just type that, get an equal sign to assign, and then I use a double quotes. And in Python, you actually can use either quotation mark. The only requirement is that your quotation marks have to match each other. So if you use a double quote at the start, you have to terminate with a double quote. If you have a single quote at the start, you need to terminate with a single quote. This can be useful sometimes. Suppose I wanted a quote inside of my string. Then I could have, say, a double quote. This is a, and then a single quote string. And in fact, that last representation, these single quotes inside will not start or end the string. They'll actually just show up when I print the string. So if I want to print this, I can just do print a string, and I'll run the cell at this point just to see what we get. And in fact, you can see what's been printed out is the version, the final version that has a quote in it, which of course is important. If you use the same variable name multiple times, it's acceptable to do that. It's not often the best case to do that, but you can do it, and you'll always, the most recent value that's been assigned to the variable will always be the one that you get. So that's a basic string. There's a really useful type of string called an F string that's new and only actually applies to the most recent versions of Python. And that actually lets us create formatted prints where we can actually mix and match regular string contents and variable names. So we're going to use the print statement to make a format string. They are just regular strings, so you can't just assign them to variables, but here I want to actually see the outcome. So format strings are a little funny. They start out with an F and then a quotation mark. That actually tells Python that it needs to do something special to this string. So I'm going to write the value of scalar float is, and then I'm actually going to type scalar float again. If I just go ahead and print that, if I run this cell, you'll see, of course, that's just a plain string. Nothing special happens there. So at this point, I haven't actually achieved anything. But what I can do in an F string is I can use braces around a variable name. And what that tells Python to do is that when it evaluates this string, it should substitute the term in braces for the actual value of that variable. Of course, it's important that the value of that variable has been previously defined, but I've already done that in my previous cell. So if I run the cell again, you now see the value of scalar float is 3.14.15. So F strings are a really useful invention that make it really simple to get basic formatted output without much effort. There are a lot of things you can do with string formatting in Python that are just way beyond what we need in this course. We'll usually stick to the basic things, just print and maybe an F string here or two. But it's useful if you actually want to do fancy things, like you can actually format the number you get. You could say I only want 2 decimal places, or if I have a very accurate number, I want 8 decimal places. You can do a lot of different things with that, but we don't need to sort of worry about for this course. The final thing we're going to learn about strings, which will be useful, is how you actually can do what's called concatenate two strings, which is put two together. And in Python, this also is really simple. It's going to be just string addition. So we're going to have two strings. First, which is simply going to be string concatenation. And second, which is going to start with a space, addition. And then finally, I'm just going to print the sum of the two strings. So if I run this cell now, let's press Control Enter, and I run the cell, you can see string concatenation is like addition. And so what the plus has done is it's actually just essentially, it's literally added these two strings together. And that's a nice thing in Python, that you can actually add two strings together. You can add regular strings and F strings. You can do lots of things. And again, this is just a useful tool when you need to produce output, because you can easily just merge strings together that you might build from each string holding some variable thing, and then you all output it to the screen in one big go. Okay, so that's a really brief introduction to strings. Again, we're just focusing on the things that we actually need to be successful in this course. There are lots and lots of things you can do in Python that just go beyond what we need. The next assignment asks us to create what's called a list. Lists are really versatile things in Python, and they're essentially containers for other objects. They're containers where you can add and remove elements from the list. And so we end up using them a lot. We'll often use them, for example, whenever we want to initialize a new array, or if we want to add or change some names to variables later. They're really going to be all over the place. They have a very common syntax, and they're going to start and end with square braces. So we're first going to create a list, and again, just continue with the same naming strategy. But we're going to have a list. So this is an empty list. I just type a list, and I put open and close brackets. That actually creates a list with nothing in it. So that's an empty list. That is often a useful thing to do, because sometimes you want to create a list and then you want to populate its values in some other code, for example, inside of a for loop or some other thing that's going to iterate across some other data. And you can do that by just initializing a blank list and then adding elements one at a time. Here we want to actually just go ahead and populate our list with a few elements. So we're going to populate it with scalar float and scalar int. And then I'm just going to go ahead and print it just so we can see what I have there. And so on the right panel, you can see at the bottom, there I have a list, and you can see it's actually just printed the square brackets and then the two elements, scalar float and scalar int. So that's a basic list, but one of the most useful features about list is I can extend it. I can actually append to it formally. So I'm going to take a list, then I'm going to type append. So I type append, and I can append any, lists can hold essentially anything in Python. So I'm going to just go ahead and put the string in there at the end. And that command doesn't have a return. So when you append it, you're actually doing what's called an in-place operation. So you don't end up replacing you don't need to reassign that to another variable. So it actually just extends the current list or appends it to the current list. Then I can just print my list again. You can see the first list, of course, just has two elements, but the third list has all three elements. So it has the float, the int, and the string. So that's another, appending is a really useful feature of a list. Lists don't have to hold they don't have to hold unique elements. I can repeat an element of a list. For example, if I append a string again, and I print it, you can see at the bottom, you now have the two numbers, and then you have the exact same thing repeated twice. So they are really generic containers that can hold anything. The other incredibly important feature that lists have, which we're going to use a lot when we actually get to what are called arrays and data frames, is they support what Python calls slicing. Slicing allows you to quickly take a subset of a list. You can also take a single element out of a list by its numeric position. For example, suppose I want to take just the first element from my list, which I can see is 3.14.15. So if I just type print a list, and then remember, one important thing about Python is it's zero indexed. So the first element has position 0, the second one has position 1, and so on. So if I want the first element, I'm just going to use square brackets and say, give me element 0. So I take a list bracket 0. That's going to give me the first one. And then if I want the second one, I can just type a list bracket 1. If I run the cell, again, you can see at the bottom are the outputs of my two commands, 3.1415 and 31415. So those, of course, are scalar float and scalar int, which we know are the first two elements of the list. So this is basics element selection by list. So you can pick any element out of a list by its position. But a more useful feature, again, is called slicing, which lets you select blocks of elements. So the most important slice for us is going to be this sort of simple slice that just has a single colon in it, and then it has a number, or possibly two numbers, that generically, this is of course not valid code because I haven't defined start and end, that if I take a list start end, what I'm going to get mathematically is I can actually use a little bit of markdown here. So if I want to actually just write down mathematically, what I'll get is I'm going to get all elements between start and end, but not including end. So in other words, it's going to be, in math notation, so it's going to be AI for I greater than or equal to start, and less than end. So if I got my LaTeX right here, and I run this cell, we'll actually see on the right side what I have. So I got that actually wrong. So of course it's LEQ there. So in other words, if I is above start or equal to start, it takes it. And it takes it right up to end, but doesn't include end. So it's really important to remember that it's not a sort of everything between start and end inclusive. It's an exclusive end and an inclusive start. This is just how Python decided to implement it. Other languages use different sort of structures. But here we have to remember that, and we're going to use this structure a lot. It turns out it's really useful because sometimes, for example, you want to select everything in a list or everything in an array with n observations. Well, if you just do colon end, so for example, if I just do a list colon end, that's exactly the same as a list 0 end. So in other words, if I omit the start, it's essentially the same as setting start equal to 0. I can also choose to omit the end. So for example, imagine I want element 1 to the end of the list. And so if I actually exclude a value at the end, that actually says take all of the elements of the list. It actually says use the length of the list. So all of these are sort of valid things. This is a really, really brief introduction to slicing. We'll see it a lot as we go through the courses when we need to take subsets of arrays. For example, we want to take all of the data in the 1970s. That will be a subset because it'll be, find the first observation, find the last observation, and it'll be the subset that includes all of those. But slicing is a really important thing. What we're actually asked to do in this assignment is to select the first two elements of the list. So there are a couple ways to do that. The first one would just be to take a list colon 2. So if I print that, you can see again, I just get scalar float and scalar int, but a list actually has 4 elements. It has the 2 strings in it as well. Of course, just because using the syntax that I just introduced, this is exactly the same as taking a list 0 colon 2. And so these are 2 basic ways to sort of slice a list that will select subsets of the list. And in practice, this is really important. It's going to be more important for us when we actually get to arrays than when we are using lists. But slicing is a good thing to introduce here because we're going to see it a lot. So moving on, another really useful feature of lists, of course, is they can contain anything, and that includes lists of other lists. And this is going to play an important role for us because when we want to construct multi-dimensional arrays, so if I want a 2D array, or what we usually call a matrix, if I want to have some rows and some columns, that's actually going to be represented in Python as a list of lists. Of course, we're going to use some additional tools to make that a more meaningful, easy-to-use structure called an array. But for now, when we actually want to initialize one, we're actually going to, as part of the process of actually entering the values, we're going to use a list of lists. So first thing I want to do is make a second list. And I'm just going to, for now, let it be empty. That's, of course, just an empty list, nothing in it. But then, of course, I can put a list inside, or in fact, in this case, I'm going to put two lists inside, the first one and the second one. And then I'm just going to populate the values. So I'm asked the first list is asked to have 1, 2, 3. The second list asks us to put 4, 5, and 6. Then I can actually just print this just so we can see what's going to happen here. So that's how it prints the list. You know, it's not the prettiest thing in the world. It actually doesn't show us that I have 2 rows because Python doesn't know that these are rows. It doesn't know how to interpret these. All Python knows is I've asked it to have a list of lists. And so it shows me a list where each element inside the list is another list. And, you know, that's the most it knows because it doesn't know that I really want to interpret this like a two-dimensional array where the first list is the first row and the second list is the second row. But we'll see in a few lessons how we actually are able to do that. So now I'm asked to select element 5 for the nested list. So I want element 5, so we can see element 5, it's in the second row in the second position. But if I remember correctly, Python is 0 indexed. So the first thing I do when I want to pick the second row, which of course is the second list, I type second list and then I type 1 because 1 is actually the second element because of the 0 indexing. So if I just print that, what I should see is I see 4, 5, 6. That's the second row. And then, of course, that's just a plain list. So I can actually just grab element 5 from that, which is in the second position. But of course, that's again position 1 because of the 0 indexing. And if I print that, we see now I have 5. So with lists, when I want to select elements of nested lists, I just work from the outside in. Start from the outside list, figure out where the element I want is, go to the inside list, figure out which positions that in. If I had a list of lists, then you might also end up using 3 levels, or you could even have 4 levels. So this is, again, a simple thing, and it just shows how we sort of select elements. You could also use slicing here. It is possible to actually, you know, select a slice after selecting an element. So for example, if I take second list and I take element 1, which again is going to be the second row, and then I take elements 1 to the end, that's going to be, of course, 5 and 6. So if I run that cell now, you see you get 5, 6, which is, you know, all I've done here is taken the sort of second element of the variable second list. And then from that list, I've taken elements 1 and 2, which are the position 2 and 3, the second and third elements in that list. So a really brief introduction to lists of lists. We'll see these a lot as we go through the course when we work on arrays and data frames and structures like that. And that's in practice how we're going to have lists of lists. We're going to not spend a lot of time working directly with lists of lists. We'll often create the list of lists and then immediately transform it into an array or a data frame, which turns out to be a lot more convenient structure. It's also more efficient. The final object we need to have some insight into is a dictionary. So dictionaries are a bit less common than lists and scalars, but there are occasions where you might need one. And so a dictionary is a key value store. So that is, you actually will be able, just like a regular dictionary with words in it, you'll have a key, which of course in a dictionary is the word, and you'll have the value, which is the definition. Here, keys can be lots of things. For our practical purposes here, we're just going to use strings as keys. And then values can actually be anything. It could be any object, it could be a number, it could even be a list. But for here, we're just going to focus on really basic objects. So we create a dictionary. So again, call it a dict. You might ask, well, why am I just calling it dict? The answer is that dict is in fact a reserved word that Python uses to initialize dictionaries using a different strategy, different interface. So you can't use dict because it's reserved. And then we're going to use braces. So braces start a dictionary, but we need to go a bit further than that. And so the key values are going to be separated by a colon. So generically, it's key colon value in a dictionary. So given what I've asked to do in this task, the first key I'm asked to use is float. So I put float, and then I put its value, 3.1415. Then when I want to add a second one to a dictionary, I'm going to use a comma, and then I'm going to put int and 31415. And then the third one is string, and I'm going to put 3.1415. And so now I have a dictionary with three things, and of course, just like always, we'll just print it just so we can get a sense as to what we actually have. And you can see it prints basically exactly what I typed. So you have the braces, which indicates it's a dictionary. Then you have the key value pairs. Python preserves the order, at least in recent versions of this, so they do come out in the order that you actually put them in. But the really useful thing about dictionary is that unlike a list, in the list example we saw, you could only look up things by their numeric positions. Again, a lot of times that's a meaningful thing because we know data is ordered. We know that, if I want 10, I want 11, I want 12, and so on. So lists, of course, are really good for that. But a lot of other types of things, we actually don't have a particular order, but I do have a name for things. And so a dictionary lets us use meaningful names, and so it lets us look up things by names. So in particular, if I want to look up the value, float, I'm just going to take my adict, and I'm now going to use square brackets and the key. I can look up anything that has a key that's in my dictionary. And so if I run this cell, unsurprisingly, I get 3.1415. I can look up any of the things one at a time. Of course, this is a limitation when you compare it to a list. A list, of course, I can use slices to pick entire blocks of sort of values. Dictionary, we have to look things up one at a time. But another thing about the useful thing about dictionary is because I can look up this value, I can look up a key, I can easily change its value. So if I simply type addict, and then I put in float, and then I assign something else to it. So I'm going to use a little division here, 22 divided by 7, which, you might have seen at some point of your career as an approximation to pi. Not a very good one, but an easy one when you're working only in fractions. And then I can simply print addict again. So if I run the cell now, you see originally it's 3.1415. Now it's not quite 3.1415. It's 3.142857 and so on. It's a big long number. But that, of course, is just a decimal representation of 22 over 7. So dictionaries allow me to have key value pairs, and they allow me to change values once I have a dictionary. I also could just add any new value to an existing dictionary. So for example, here I'm asked to add a better float as a different representation of pi, 3.141592, so slightly more accurate. And then if I print what I have there, you can see my dictionary now has a new element. So it still has float. Float, of course, is still the 22 over 7 like it was when we left it at the end of the last cell. But at the very right side, you can see better float and 3.141592. So that's the easy way to add dictionaries. So now that I have this better number in there, maybe I want to go ahead and get rid of float as well. Well, there's a special keyword called del, of course, for delete. So I can just type del and then addict, and I want to get rid of the key float. And then if I print addict again, and I run this cell, you can see in the very bottom line, where I've printed it, that float is no longer in addict, that it has actually been removed, it's been deleted, and so it is possible to modify a dictionary easily this way to add, remove, and change keys. So this is an incredibly brief introduction to a few of the key built-in features of Python that we're going to use throughout the course. It's important to just introduce these slightly separately rather than when we get to them, because they do have their own uses, and again, you might find them useful when you're working on some assignments or you're working on some code. When you want to, for example, store things, you might store it in a list or a dictionary. Then later on, when you get to the end and you're ready to actually output the results, you'll have all of your sort of information stored in a convenient way that you can then access by, say, key if you stored it in a dictionary.